Leetcode problem 1764. Form array by concatenating subarrays of another array. So we are giving an array nums and we are giving an array groups. So inside the groups there are going to be several groups. So for example, for the first group, this is 1 minus 1 minus 1, and we need to find the first index, which is going to be index 3. It's going to be here 1 minus 1 minus 1, and for the second one it is 3 minus 2 0. This is 3 minus 2 0, so it's going to be index 6. Yeah, so it's going to have a group sequence. So this is going to be the first one, the second one, and this is also the first one and the second one. It has the same sequence and there's no intersection with each other. So this means 1 minus 1 minus 1 it is here, 3 minus 2 minus 0 it is here, because there's no intersection. So this is okay, we're gonna return true. Otherwise, if we cannot find it, we're gonna return a false. Yeah, so basically for solving such kind of problem, the easiest way or the straightforward way is just using a KMP algorithm. Yeah, because by using KMP, and this is our string, so for example, and for each of the group it's going to be a pattern. So this is going to be like a pattern matching problem. So we're going to check all the groups. So how many groups in total? So the sum of the sum of the group I length is going to less than 10 to the power of 3. Yeah, so in total how many groups and how many numbers in total it's going to be 10 to the power of 3. So this is our string matching actually. And for this nums, the length is going to be 10 to the power of 3. So the final time complexity is going to be 10 to the power of 3 plus 10 to the power of 3. So this is why KMP would be the best way to solve the problem instead of this number times this number. But currently, if we are going to use the KMP, it's going to be this number plus this number. So this is going to be the final time complexity. So for the KMP algorithm, let's first write a next array. So it's going to be a 3s. Let me just prepare the next array. So here I'm going to prepare a -1 and -1. So this -1 is going to be a dummy place. So this will be easier for the next array calculation. So now if j more than equal to 0 and si not equal to sj, so it's going to be j going to be jumped to next j, and then j gonna plus equal to 1, and next gonna append this j. But here the first loop gonna be I in range length of the string s. Yeah. Now we're gonna prepare the next array. So finally we're gonna return this next array. So the second step is that we're gonna try to find all the positions. So for example, the first one, this position is gonna be index 3, and we also prepare the length. We're gonna prepare a 3 and 3. The first index is gonna be the position, it's gonna be index 3, and the second one gonna be the length, because I'm gonna use this kind of information to solve the problem. Yeah. So for example, basically I'm gonna prepare a result. So the first one gonna be index 3, and the length gonna be 3, and the next one the index is gonna be 6, and the length is gonna be 3. Yeah. So this is possible because this is 3 plus this is 3, it is 6 less than or equal to 6. Basically this means we can put the next position. Yeah. But if this is a 3, the length is 4, it is 7, 7 is more than 6. This means there is an intersection between each other. Definitely it is not possible. Yeah. So basically we're gonna prepare such kind of a result. Yeah. So result is gonna be an array. And finally I'm gonna check the length of the result equal to the length of the groups. If they are equal, it means it is true, otherwise it's gonna be false. Now let's just put anything inside the result if it is possible. So we're gonna check all the group. Yeah. So for group inside the groups, now we're gonna use the string matching algorithm by using this KMP, by using the next array. So I'm gonna set next array equal to the next with this function. I'm gonna call the group. Now I produced a next array, and I'm gonna prepare index j gonna be 0, and then for I yeah, the time complexity here, I think I used yeah, it is 10 to the power of 6 maybe, because this is a group. The total number of group gonna be 10 to the power of 3 times 10 to the power of 3, so I think it is 10 to the power of 6 here. Yeah, I used 10 to the power of 6, but let's just start it coding. Yeah, it is 10 to the power of 6 I used. It is not 10 to the power of 3, but let's just start coding. So for I in range and length of the nums, so while j more than equal to 0 and nums I not equal to current group j, so j gonna equal to the next array with this j. So yeah, if it is not equal, so this is the basic pattern of a KMP. If it is not equal, so j gonna jump to the next array with this j, and j gonna plus equal to 1, and here we're gonna have a tag. So this is just the basic pattern. So if j equal to the length of this group, so basically we can prepare the final result. Yeah, but currently we cannot put it inside of the result array because we are not sure which one we're gonna put. We have to put a 1 if it meets the condition. So for example, if it meets this kind of condition like 3, 3, 6, 3. If it meets this kind of condition, definitely we're gonna put it inside. If it didn't meet the condition, we will not put it inside. So here we just need to have a stencil tag. Yeah. So our tag is that we're gonna check the result array if the result array is empty, or the sum of result minus 1 is less than and equal to I minus j plus 1. So this result, sum of the result minus 1 is this 3 plus 3, and this I minus j plus 1 is yeah, let me just think about it. Yeah, is this index 6? This is the current index 6. If it meets the condition, we're gonna put it inside. So result gonna append I minus j plus 1. This is gonna be the index position and the length of the group. And if we can put in 1 inside, definitely we're gonna break it. Yeah. So here, if this is j equal to the length of the group, so basically, so this is gonna be the index nums. If we find 1, so for example, this is a 1, it is okay, we find 1. But what about this is not okay, and this I gonna continue to tag. Yeah. But for this j, it's gonna be set to 0. J gonna be here, maybe I gonna be here, maybe we want to find the next one. Yeah. Even this j equal to the length of the group, but if it didn't meet the condition, we will not put it inside. So if we didn't put it inside, we're gonna check the next I position. So this means if we didn't break it, so the j gonna set to 0 because we want to find the next one if it is possible. Now let me just run it to have a check. Now as you can see, it works. I think it's a lot of coding, but the basic idea is the KMP. We just need to use KMP to solve the problem. Yeah, as you can see, it works and it's pretty fast. Yeah, it's like 0.1 seconds. And now let's analyze the time complexity. So for here, this is a for loop. So for this for loop, basically we're gonna check the length of the group. So the length of the group, what is the length of the group? Yeah. So the sum of the group I length. So the total number, the sum of the group length is gonna be 10 to the power of 3. Group I dot length. Yeah, it's gonna be 10 to the power of 3, and each of them gonna be 10 to the power of 3. So this is just a special case why this is running so fast. Because here, basically, we are going to check how many groups. But for here, basically, this is a string matching. So the length of the nums is going to be 10 to the power 3. This is the nums length. And from here, we're going to check it. Yeah. But as we can see from here, if this is a KMP, basically, this is the time complexity for here. It is just 10 to the power of 3, because basically it m plus n. Yeah, and m plus n is like 1000 plus 1000. Basically, the time complexity is still 10 to the power of 3. But here, we are going to check how many groups. So this is limited how many groups. If there's only one group, for example, it is 10 to the power 3. Of course, it is 10 to the power 3. But if there are 10 to the power 3 groups, basically according to the problem, it's going to be 10 to the power of 3 groups. So the time complexity is going to be 10 to the power of 6. Yeah. I think that's all about it. Thank you for watching. See you next time.